All right, good afternoon, everyone, and welcome to our Intelligent Scale Solution webinar. I'm your host, Greg Jackman, the Specification Program Specialist here at Watts. Today's webinar is the next installment in our series of webinars geared specifically for you guys, our engineer, architect, and specifier customers. Just to give you a little background on this series, we hold several webinars throughout the year that cover a variety of topics. Our presenters are in-house technology and product experts, and thanks to our partnership with the American Society of Plumbing Engineers, ASPE, we're able to provide you with 0.1 continuing education unit, CU, credit if you stick around for the entire webinar today. After today, our next one will be held on July 30th, where we'll be talking about snow melting solutions, and on August 22nd, we'll be hosting one on Legionella control. So if you're interested in either one of those, please keep your eye out for our emails to register, or you can reach out directly to me at gregory.jackman@wattswater.com, and I'll sign you up. So with that being said, I'd like to introduce you to the presenter of today's webinar, Peter Hewitt, our product manager of OneFlow Solutions at Watts. Peter recently joined Watts back in December of 2018 and has been dealing with water treatment solutions for several years now. During the duration of Peter's presentation today, the phone lines will be muted, but we encourage you to submit questions via the chat window. Just hover over the chat icon at the bottom of the WebEx and type in your question there. We'll then address them after the presentation. So with that, let me pass it off to Peter to get started.
Thanks, Greg. Welcome, everybody. We really appreciate your time today. It's a great pleasure to help transfer some ideas and knowledge and information about OneFlow and other TAC technologies that are out there. And so with that, next slide, let's get started. So as Greg pointed out, this particular course is approved by the ASPE. So you can follow through and take advantage of this as future credits for your professional acknowledgement. Next slide, please. And at the end of this course, we're hoping that you'll be able to obviously learn a lot more about TAC technologies, identify key issues with scale formation, how they relate to equipment reliability, performance degradation, health and safety, evaluate the performance of scale control technologies, and describe the science and benefits of TAC, template-assisted crystallization, and compare cost effectiveness as this technology is a more sustainable alternative to conventional water softening. Next slide, please. So let's talk about the benefits right away up front, and we'll go through a whole bunch of other slides of information to give you some background on how it works and what the applications are. But think of it as consistent scale control performance for whole buildings, whole house applications. Residential and commercial are the main sectors. No salt or chemicals are required. No control valves, so there's no moving parts or mechanical systems that require electricity. No wastewater, no drains, no water down the drain like conventional softeners. It's a simple installation with really virtually maintenance-free for several years until the actual media needs to be changed. And it improves the efficiency of water heating devices and equipment and downstream components, fixtures. We'll get into more detail on that as we go. It's a very compact footprint, as you'll see, compared to softening technology, and much lower maintenance costs compared to softeners, and retains beneficial minerals because nothing is added to the water or taken out of the water. So calcium and magnesium, which are good for people, are retained in the water itself. Next slide. As you all know, hard water is a problem. If left untreated, it can really cause problems in piping and plumbing infrastructures and valves and system components. And over time, this scale buildup can reduce water flow and increase costs and shorten plumbing lifespans. Next slide. Next slide, please. There we go. this is taken from the Water Quality Association. About over 2/3 of the country has hard water, and in some regions it's a serious problem that's affecting a lot of the plumbing infrastructures. But really, the important thing to understand with TAC technology is it's a conditioning technology. It's not a filtration technology, but we'll talk about that. Next slide. So let's continue to highlight the key issues on scale formation. Equipment reliability, we touched on it earlier, but we've gotten feedback from interviews with hospital maintenance teams, for example, and scale buildup on thermostatic mixing valves was identified as one of the most challenging maintenance issues. And we all know about other issues related to problems with water heating equipment and fixtures and the like. And then there's also just a performance degradation issue that can really have a direct effect on operating costs. So scale acts as an insulator and causes a reduction in energy efficiency. And some studies have found that, up to 1/16 of an inch of limescale buildup on hot water heaters can increase the fuel consumption up to 15%. So degradation is definitely front and center as an issue when scale is left untreated. Next slide.
Looks like we're having an audio issue right here. Just hold on a few seconds. Peter, can you hear us?
Yes.
All right, go ahead.
Can you switch the slide? There we go. So other issues, health and safety. There's been some outbreaks of Legionella in certain areas of the country, mainly due to and associated with cooling towers, where TAC technology is really ideal on open loop domestic water systems. So, but it is something to keep an eye on and have a management plan in place for your facilities. Aesthetics, scale is the culprit for spotty glassware and soap scum buildup in dingy faucets. And over time, this can become a problem that causes increases in cost to replace. Next slide. So think of traditional scale treatment as sort of three categories. Ion exchange is conventional softening. It's been around for decades. Obviously, it has a controlling aspect on spot-free rinsing and trying to prevent scale formation. But there's a bunch of trade-offs that come with softening, and that's mainly due to excess amounts of sodium that enters the water stream in a building or a home. And it's also got a lot of wastewater, which impacts the environment and causes downstream issues with municipalities that have to treat the water that has heavy sodium content. And then just the maintenance aspects of ion exchange with the salt being replenished and labor associated with that and proper dosing. And so it's just a very much more intensive maintenance requirement. Chemical treatments like phosphates and others are also trying to make their way to cause scale control. But also they can effectively control corrosion, but again, constant introduction of chemicals into the water stream is not necessarily the best way to go, particularly when there's environmental impact based on that wastewater. And then electromagnetics is another category. And again, there's no consumables or additives, but again, some of these gizmos out there have actually failed to pass any standard scale control tests that are designed by internationally recognized agencies. So next slide, please. We really are interested now in trying to create and establish the difference between TAC technology and methodologies for controlling scale. Next slide. So TAC has been tested for over 10 years in real-world applications and has been proven to continually outperform other scale remediation processes. I'll talk a little bit about this research. Next slide. So Arizona State University, in contact with the Water Reuse Foundation, did a third-party validation study several years ago, which essentially showed that TAC, for example, was up to 99% scale control using the technology. And Dr. Peter Fox is one of the nation's well-known water expert and environmental engineering experts. And he basically has been quite outspoken about the values of TAC compared to these other technologies that were previously discussed. Next slide. And so there's ongoing technology research that we do as well as others in the global world of water technology. The German standard DVGW, the W512, for example, is a standard test that can be reenacted and proves the efficacy of TAC, as evidenced by the pictures. So that's a particular standard test that has been adopted quite readily across the world. Next slide. So how does it work? So the interesting thing is, because nothing's added to the water, there are these bead resins, TAC bead resins, that are inserted into each either cartridge-based system or tank-based system. And what happens is that when water comes into contact with these bead resins that are specifically coated with a proprietary formula, that they end up causing the calcium and magnesium minerals, which are most commonly found in hard water, it causes them to grow microcrystals and bind to each other and then get passed through the water distribution pipes without adhering to metal surfaces. And so this is a physical condition that occurs. And again, it was tested thoroughly independently, and then through about a decade worth of real life experience, we've seen all the different applications where TAC works effectively, and we'll talk more about that. Next slide, please. So one of the technology features here is the fact that the systems, and these are two tank visuals that show you that the system is an upflow fluidized bed. So the media is down at the bottom of this tank on the left. As water enters the inlet at the top, goes down a riser pipe, it comes back up through the media, causing it to fluidize, almost like a snow globe. If you turn it upside down and shake it, you get the same sort of implication. And then, again, water just passes through the outlet, and these are usually 2-inch on our larger tank sizes, so 2-inch connectors. And next slide, please. And so, as you can see, the portfolio here of cartridge-based systems and tank-based systems, there's really quite a wide array, really based on the GPM and flow rate requirements. So obviously the cartridge systems are much smaller and therefore smaller flow rates. All the way up, we've seen high-rise condominiums and apartments and hotels that have the large series of large tanks that can deal with flow rates all the way up to 1,000 GPM or higher. Obviously, those peak flow rates are calculated based on fixture count roll-ups. But next slide, please. We'll talk more about this. Feed water requirements are always important to understand. The one thing with domestic water treatment, it's really necessary to always understand what's in the water. So water quality testing is always recommended, and these are some of the residential requirements for feed water. Next slide. These are compared to commercial applications, and this kind of information is available on the Watts website. You can download the engineering spec sheets and installation manuals and whatnot that also publish these requirements. Next slide. Other precautions that we always suggest and talk about are obviously the chlorine levels and what that can do to impact TAC media. Actually, having carbon filtration in front of TAC systems is an advantage to lengthen life cycles and therefore controlling the amount of chlorine. Iron, manganese, excessive iron, these are issues that can cause the media to foul just as copper can as well. So it goes back to knowing what's in the water always. Next slide. And so these are some key commercial applications that we've had examples in with healthcare and hotels and resorts and schools and high-rise multifamily projects and mixed-use office buildings. So there's quite a wide variety, and it all comes down to system design. Next slide. And then, of course, the audiences of decision-making, building owners and property managers and facility engineers and really the plumbing engineering firms and professionals, as well as architects and contractors and developers and owners of projects. All of these groups are involved in the decision-making process. So it's important to convey the advantages of TAC over some of the conventional water treatment technologies. Next slide. Installation requirements, again, flexible connections required mainly because when water comes down from a main water line into the system, it can cause, some jolting of the tanks, and therefore, having flexible connectors is important. Seismic strapping is important in many regions of the country. Vacuum relief valves may be necessary, particularly if the water heating equipment is up on the roof or above the ground floor where the tanks are. All sorts of pipe hangers are usually necessary, depending on the size of the system, particularly in the commercial applications. And then sometimes, heavy loads of dirt and sediment may require pre-treatment, pre-filtration that we can address as necessary. Next slide. So again, just very simply here, you can see the installation differences between TAC and water softeners, and no electricity, no water drainage, no wastewater. So much simpler installation requirement. Next slide. Space savings, the footprint of a TAC system is much smaller, sometimes up to 85% less when you calculate storage of salt. I mean, I've been in some mechanical rooms where you can't even practically move through the room. There's so many pallets full of salt bags. So again, space savings is a real advantage, particularly when mechanical rooms are so tight for equipment. Next slide. We do present some cautions. Closed-loop systems, heating systems, are sometimes an issue where we might not recommend a TAC system. So really, open loop is the ideal scenario. And in some cases, we've seen where whole building systems for conditioning with TAC are superior for plumbing infrastructures, but there may be some spotting on commercial dish machines, in which case we do recommend a point-of-use small softener, usually fits underneath the rack of a commercial dish machine, just for that application. Next slide. Cost savings, just if you go down to the bottom of this slide, it's a little heavy in tables and graphs, but down below you can start to see, because of the operating costs associated with softeners, there's a much better return on investment and essentially operating cost reduction based on TAC versus softeners. Next slide. Media replacements are recommended every 3 years in the tank systems and 2 years in the cartridge systems, and smaller ones maybe cartridges replaced every year. And then again, in the tank systems, you can basically use a siphoning mechanism to extract the media and water while the tank remains upright, or you can actually, in method 2 there, pull out the water and then tip the tank over and suction out the media and replace it with new media. So that's once every 3 years on commercial systems. Next slide. So in summary, TAC is a better solution. It basically is more economical, simple, and permanent. It's easy to design, install, and maintain, longer lifespan for capital equipment, certified by the WQA, environmentally friendly. This is a big thing with the world of sustainability before us. So next slide. What we hope that you can walk away with, and obviously we have a lot of materials and information, and our websites are really a great place to download information and resources, but we're hoping you can identify the fact that there are key issues with scale formation and water treatment requirements and how they relate to the reliability of the equipment that many of you designers are implementing in your design build projects. Simple eye test to evaluate the performance. We are looking at some other water testing scenarios to determine effectiveness. Describing the science and benefits of TAC as a scale control technology, and measuring the performance and efficiency of TAC by utilizing the Langler saturation index is this reference I'm making to testing that as a methodology, and compare the cost effectiveness of traditional scale control technologies. Next slide. So that's pretty much the wrap-up. I think there's some availability of Q&A. Greg, can you help us out?
Yeah, we had a few chat questions come through during your presentation. The first one here is one flow applicable to be installed pre-steam boilers?
So steam boilers are somewhat of an issue because of the significantly high temperatures, very high temperatures. And so we'd have to look at it on a case-by-case basis, particularly, where it comes into play for whatever commercial building you're implementing this heating technology for. I would steer away from one flow for steam boilers, but again, we're open to sharing some case-by-case knowledge.
Okay. Next question. If we place carbon filtration in front of TAC system, we will be removing chlorine, which is a disinfectant for the water system. Would we then need to treat the water for biological protection?
So the answer to that question is depending upon how much carbon and the size of a carbon tank you're utilizing, because sometimes carbon and chlorine reduction is not 100%, and so it can still be a disinfectant on a certain percentage. So it's a system design requirement that needs to be taken into account. But there are literally thousands of applications out there that have carbon in front of TAC and work very effectively.
Okay, thank you. Next question, does higher water hardness require more frequent changes of media?
So again, just like other technologies, the idea is just through experience, we recommend a change out every 3 years. So depending upon the hardness, it's really not going to necessarily impact the life cycle of the TAC media on the inside. But again, it's always good to know what those, via water quality testing, what those feed requirements are or what feed results are. So again, that's pretty much the recommendation is we've stood by 3-year changeouts.
Do you base replacement on pressure drop?
Say that again, please.
Sorry, do you base replacement on pressure drop?
So there's less than 15 psi pressure drop through any series of TAC systems. So it's a very minimal amount, particularly when you're in front of booster pumps, which is what we recommend in high-rise buildings that have booster pumps. So the system would be ahead of a booster pump, and therefore pressure increases can be controlled. So you can use the less than 15 psi drop as a metric.
Okay. And how does TAC compare to 3M's AquaPure scale stopper?
So I've heard of it. I don't know a whole lot about it. You know, we can do a little bit more investigation if you'd like. If it's based on, can you give me more information, maybe via email, and we can explore that?
Yes, I'll make a note of that. Next question here. I live in an area of West Virginia that has approximately 18 to 20 grains per gallon, 308 to 342 milligrams per liter, with a traditional water softening system. Very interested in this technology.
Sure. It would be applicable under those conditions. And of course, the important thing to know, if it's well water, what is in the water. So hence a water quality test that identifies the elements and the conditions beyond hardness of what's in the water is important to know.
Okay. If the pH is not being changed, how is the LSI being affected by OneFlow?
So I'd appreciate that being sent via email because there's some issues we're dealing with on that particular topic. And our engineers and I have an ongoing discussion currently. So please send that in via email. We'll address that.
What is the typical cost of the media replacement?
So it can be on a liter by liter basis. And so the first thing is to understand, you know, how many tanks you have. If it's a commercial application. And then from there, it's a variety of price points that we don't necessarily want to quote right now, just to know that if you have a specific application, we can give you a much better idea. And that's our sales rep organizations across the country usually deal with specific pricing and whether it's being sold through wholesalers or dealers or whatever. So I'd rather not get into that right now.
All right, next question here. Has Watts used TAC on cooling tower makeup water and measured the results?
No. And again, with cooling towers, the amount of chemicals that are introduced in those applications can affect the objective of TAC. On the other hand, sometimes point of use softeners could be implemented. Again, there's a lot of different theories and philosophies about water treatment for cooling towers. So it's an area that we really don't recommend for TAC.
Okay, and this next question is a follow-up from a previous one. Does water conductivity change before and after OneFlow?
Water connectivity.
Conductivity.
The answer is no.
Okay. Is there a minimum flow rate per unit of media?
So again, flow rates are going to determine what size of a system is recommended. And so yes, liters of media are relevant to the size of the system, whether it's a cartridge-based system on low, 1 gallon to 10 gallon per minute flow rates. And obviously in commercial buildings, you could see flow rates from 100 to 1,000 GPM. So again, it's the kind of thing where system design is predicated on understanding peak flow rates, continuous flow rates, occupancy rates of buildings on the commercial side, water usage on the residential side. So there's variables to consider.
All right, and this refers back to a previous question as well. To expand the replacement based on pressure drop question, can you determine if the media needs to be replaced before the 2 or 3 year time by looking at pressure drop across the TAC system?
No. Pressure drop, as I said, is not going to be impacted through the system other than a less than 15 PSI drop, and that won't affect necessarily the media. And then afterwards, in getting water distributed up through commercial buildings with booster pumps and the like, you can control increases to pressure.
And what is the maximum TDS?
TDS?
TD as in dog.
Yeah, TDS. So again, back to that slide on TDS, it's again a feed water requirement. So I don't know if you want to zip back to those 2 slides, Greg. They had residential and commercial feed water requirements. So down below there's for the residential. I can't really read it because there's a symbol blocking my bottom of my slide. What's that, 500 milligrams? And then go to the next slide, commercial. So again, 500 milligrams is the answer.
Okay. Follow-up question on using Watts TAC on cooling tower. The question is, if TAC has been installed on the makeup water to the tower, not TAC on the recirculating water in the tower, removing minerals to the makeup water to the tower can reduce the blowdown and treatment rates of the recirculated water in the tower.
But keep in mind, we're not removing minerals, right? We're converting minerals to grow microcrystals to bind to each other. So there's a misunderstanding on the fact that TAC is not removing minerals on makeup water.
Okay, thank you. If anyone else has any questions out there, feel free to put them through the chat window here. We do have a few more questions that I'll run through. How does upfront cost compare, TAC versus traditional softener system?
So think of it as capital costs and operating costs. And capital costs, I would say, are not too dissimilar because you're buying the systems. You may be leasing the water softeners. Again, I don't know exactly how you're set up to manage capital costs, but the biggest difference is operating costs. So there was one slide that we showed that actually I referred to the bottom of that slide, Greg, that showed the comparison. I don't know if you can get to that. Go back.
Go back a few. Okay.
Yeah. Well, it's actually the other direction, sorry. But the fact of the matter is you have to look at operating costs and capital costs. And capital costs can ultimately be, there we go. You can see down below there that operationally, TAC systems are much less expensive. And really you're factoring in media changeouts or rebedding media or cartridge replacement in the case of smaller systems. So capital costs up front, it all depends on the system and more importantly, the vendor you're choosing and how they structure they may lease the equipment. Again, those parameters are all sort of different. So it's a case-by-case scenario.
Okay. Do we connect to a local rep or your office for equipment selection?
So you can go to the website. I don't know, at the very end, I think we had some URLs for website links. And that's one way. And then sales reps that represent us around the country regionally are also very good resources. And they can help not only define requirements, but in some cases, size systems.
Okay. Does TAC have the same or similar effect as soft water of getting soft hair after shampooing?
No, that's one of the advantages. Again, softening replaces some of the minerals and has a different feel to the water and to the body, human body, and TAC doesn't have that impact.
Okay, next question here is, are slides available on a website after presentation? And I can take that one. They will be available on our website on our on-demand webcast page, which I'll go over after we're done with the rest of the questions here. One more question here I have is, are one-flow beads charged?
Charged with what? And the answer is probably no. It's a proprietary manufacturing process that has a lot of heating elements to it and baking elements to it, but not charging. And I'm not sure what exactly you mean by that.
Okay, if you want to follow up with that question, but here we go. I mean, do they have positive or negative charge?
No. That's more related to electromagnetics and ways that you'll see some technologies out there for wrapping pipes with wires and doing that sort of, charging effect. We don't have that with TAC.
Okay, excellent. That's all the questions we have. So once again, thank you, Peter, and everyone who joined us today. Just to let you know, a recording of this presentation and your CU credit will be emailed to you. If you have any other logistical type questions, you can direct them to me at gregory.jackman@wattswater.com. And for more technical and topic related questions, please reach out to Peter at peterhewitt@wattswater.com, sorry. And like I was saying before, once this WebEx ends, it'll bring you to a page where you can choose to sign up for our next webinar on July 30th on snow melting solutions. You can visit our website, thescalesolution.com, which is our one-flow page to learn more about TAC, or you can visit our on-demand webcast page where you can watch the recordings of all our past webinars in this series and take a quiz to earn more Ask BCU credits. So thank you once again for joining us today, and enjoy the rest of your week.
Thanks, everyone.